Alright, so we're going to look at a special type of probability distribution today called a normal distribution. And in this section, we're going to be describing and applying something called the 68, 95, 99.7 rule. Better way to say it is something called the empirical rule. And in this first video, we're also going to describe the standard normal distribution. And we're going to look at table A from the back of our textbook to help us figure out how to use tables to find percents. So the rest of this, the normal distribution calculations, assessing normality, that's yet to come. We'll focus on that in the next video. But here we go. So normal distributions, what are they? Well, they are density curves. They are normal curves. So normal, what does it mean? Well, it means they're symmetric. It means they're single-peaked, and it means they're bell-shaped. A specific normal curve is described by giving its mean and its standard deviation. What that says is it says where the center of the bell is going to be, and it shows us how spread out the edges of the bell is going to be. So here are two normal distributions, two normal curves. They have different means and different standard deviations. Notice for the smaller standard deviation, the bell is taller and skinnier, while the bigger standard deviation, the bell is shorter and flatter. That's going to be the case because the area underneath them is always going to be 1. Remember, it's a probability distribution. So, going a little further, here's our official definition for normal distributions. Better write it down. The mean of a normal distribution is the center of the symmetric normal curve. Oh, that's interesting. So, if we have one of these normal bell curves, the mean is going to be the center. Interesting, very cool, very useful. The standard deviation is the distance from the center to the change of curvature points on either side. Okay, so let's talk about what that means because it's not real obvious. So we have this bell curve right there. The center, it says, is our mean. Right about here, and right about there is where the curve stops being an upside down curve and starts being a right side up curve on both sides. So frowny face, happy face. These points are what we call points of inflection. They're where the curvature changes. And whatever that distance is, and it's going to be the same both ways if it's a true normal distribution, that, ladies and gentlemen, is our standard deviation. Nifty, isn't it? The abbreviation we use for a normal distribution is N, capital N, parenthesis, then two numbers, mean, comma, standard deviation. This isn't an ordered pair, but it's the parameters for the normal distribution. Mean, standard deviation. Now, what do we use these for? Okay, well, normal distributions are good for some distributions of real data. It shows up a lot. Normal distributions are good approximations of the results of many kinds of chance outcomes, so flipping a coin, rolling a dice, those sorts of things. Sometimes a normal distribution does a good job of approximating what's happening. And there are a lot of things that we're going to do later where we perform statistical inference procedures that are based on normal distributions. So that's yet to come. But this idea of a normal distribution, it's a big one. It's a good one. It's an important one. So here is our 98, 68, 95, 97 rule. I will call it the empirical rule. Although many normal curves, although they all look different, they have the same properties. And it follows this rule. It's called the empirical rule, and it has these numbers for a very specific reason. For every normal distribution with a mean mu and standard deviation sigma, approximately 68% of all observations fall within one standard deviation of the mean. That's what this means. One standard deviation of the mean. Approximately 95% of all observations will fall within two standard deviations of the mean. And finally, approximately 99.7 of all observations will fall within 3 standard deviations of the mean. So on this bell curve down here, let's fill in our percentages. So that light purple color, 68% of all our data will be within one standard deviation. And these are standardized scores down here. These are our z-scores. Mean of 0, standard deviation of 1. Within 2 standard deviations, so from -2 to +2, 95% of all our data is in there. And within 3 standard deviations, 99.7 of all data will fall within 3 standard deviations of our mean. Onward, so we have the Iowa Test of Basic Skills for 7th graders. In Gary, Indiana, it's close to normal. And we took all this data and we found that it was pretty symmetric, one peak, and it had a mean of 6.84 and a standard deviation of 1.55. Remember, this notation means it's normally distributed. Here's our mean, there's our standard deviation. Sketch the normal density curve for this distribution. All right, so we draw the curve, we draw a number line. In the middle goes the mean, 6.84. And if we're going to do a real good job with this, the place where our curve changes curvature should be 1.55 units away. So 1.55 units would be 8.39 and 5.29 below. So this is 1 standard deviation. This would be 2 standard deviations, and we're below, so it's negative. Negative 3 standard deviations. This is 1 standard deviation, 2 standard deviations, 3 standard deviations. When you label your x-axis, set up your number line in this way. The mean goes in the middle, and then label your intervals as 1 standard deviation, 2 standard deviation, 3, and so on. So this 8.39, that's 6.84 plus 1 times 1.55. This 9.94, that's 6.84 plus 2 times 1.55. And so on. I could do that for all these values. So there is my normal distribution. There's my normal density curve. And for part B, what percent is less than 3.74? Well, I shade in what I'm looking for. So I shade in this tail that's less than 3.74. We know that between 2 standard deviations, 95% is in here. So this red shaded part represents 95% of all of our data. So how do we know that this is 2.5%? Well, if the middle part is 95%, then these two things together have to make up the remaining 5%. So that means one of them would be 2.5. What percent of the scores are between 5.29 and 9.94? So this time, here's the picture that we're looking for, 5.29 to 9.94. We know that 1 standard deviation, the red shaded part, is 68%. And we know that 95% are within 2 standard deviations. But what I'm really looking for is just this part out over here. And we can find that by taking our 95% minus 68%. That's going to tell us how much is on either side here, but I only want half of that, so I chop it in half. So 68% plus 13.5% gives us our total.